Good afternoon and welcome to a Triple Three Thursday. And let's tackle some Delta Math. Number 2.1, Operations with Fractions. As you can see, I already started this one because started making the video at school, and then I got cut off and lost the video. So let's start again. Here we go. So you can follow along from home, and I'm going to work through each one of these topics in a row. So if you're like looking for things on table of equivalent ratios, you got to tune in at that point in the video, okay? You know how to navigate a video. You're tech savvy. And if you have any questions, hit me up by email. So simplifying fractions is our first one. 50 over 75. All right, so we want to write this in as simple a way as possible. So the first thing I might do is I might copy this question down. 50 over 75. I might do that for super clarity. And then I can find a new way to write that. I can do that with factor trees. Here is 50, and I know that that's 5 times 10, which is 2 times 3. Give me a second. 10 is 2 times 5, Mr. Jennings. Okay, so I can write this as 2 times 5 times 5. 2 times 5 squared. 5 times 5 is 25, so 5 squared. All right, and then I divide that by 75. Well, 75, that has a factor tree too. That's divisible by 5, and then out comes, if I divide this by 5, well, I get a 15. That's a weird way to break it down. I would probably break the 3 out first. 15 gives me 5 and 3. So this also has a 5 squared in it, but it has a 3. So this is 3 times 5 squared. And so when I simplify this will cancel, that will cancel, and I'm left with 2/3. That's equal to 2 over 3. Okay, so when I put in 2/3 here, tell me I'm right. Okay, there we go. So I'll do one more to show you how I can do it. It gave me the same question in a row. Oh my goodness. Oh wait, no, that's not the same question. That's 25 over 75. So that if that would be 1 times 5 squared, well, that would be 1/3. Let's try one more. 54 over 70. Well, that's a little bit more interesting. All right, so 54 over 70. Copy it down. I want to find a new way to write both of those. So maybe I say, well, this is 7 times 10. All right, I don't see a factor of 10 in there, but there is a factor 2, and it's 7 times 8, is it not? 54 divided by 2 is equal to 27. It's not. And then this is 3 times 3 times 3. Right? Right. So this is actually 2 times 9. I'm sorry, 2 times 27, or 6 times 9. Yeah. So I actually need a different factorization of 70. I want to find this factor 2 in there. So what I'm going to do is change that 10 to a 2 times 5. I thought I wasn't going to need a factor tree here, but I clearly could have been helped by one. All right. And then I have on top 2 times 3 times 3 times 3. 3 threes, so that's 3 to the 3. That's 3 times itself 3 times. Use an exponent there. It's more beautiful. And then the 2's cancel, and I'm left with 9 over 35. 27. 27 over 35. I seem to have left my math brain at home. At school. Everything I say is wrong. Everything I write down is wrong. But did you notice I caught my error? Did you notice I caught it? And that's really a useful skill, everyone. Modeling growth mindset. Sometimes your game isn't really there, but when you notice your mistakes, you can fix them before they hurt someone like yourself. Okay, so let's go on to the next topic. So multiply and divide fractions. All right, multiplying and divide fractions. That was our topic from Wednesday. So here, when we're multiplying fractions, there's not that much that we need to do. We need to copy down the question, 2 over 7 multiplied by 10 over 9. And then we can check here and see if there's any factors that we can cancel. I think someone was calling this cross cancel today, and you can absolutely do that. But there's not. 2 doesn't share any factors with 7 or 9. 10 doesn't share any factors with them either. So I just have a new line, and it's 2 times 10, top times top over bottom times bottom. You can skip writing this out if you want to go straight to this line, 20 over 63. 20 doesn't share any factors with 63, so that is fully reduced. All right. So we want to make sure that this answer gets fully reduced. You'll see over there they ask for it to be fully reduced. So do that. So this is 20 over 63. Oops. There. Okay, let's do one more. 9 over 5 times 8 over 3. Well, I'm going to have to dig to get it to give me a division question. But this one is 72 on the top over 15. But 9 and 3 share a factor, so I can cancel those. So that would leave on the top 3 times, I would write this one down, 9 over 5 times 8 over 3. When I factor out the 3 from the 9, this would have been 3 times 3, but then a 3 on the bottom, they cancel. So that gives me 24 on top, which is 3 times 8 over 5. It's the only thing left there. So 24 over 5. Hey, let's do another one. It's going to tell me you're all done. I'm going to say, okay. There we go. Yeah, do this one. 5 over 2 divided by 5 over 4. Oh, well, would you be annoyed if I told you this is 2? Okay, it's 2. What we're saying is how many times does 5 over 4 go into 5 over 2? This is half the size of that. Because this is 5 quarters, this is 5 halves. All right? So this goes in 2 times into that. So anyway, that's just how you would look at it and imagine it. But when I have 5 over 2 divided by 5 over 4, with division of fractions questions, what we want to do is keep the first one, turn it into multiply, and flip the second one. Okay? Multiplication of fractions is exactly the same thing as division when the back one is flipped. And so now I just do 5 times 4 on the top, which is 20, over 2 times 5 on the bottom, which is 10. 20 divided by 10 is 2. So that's how you do division of fractions. All right, let's keep going, everybody. Converting fractions to decimals is a very useful skill. If I want to convert 13 over 40 to a decimal, guess what I do, folks? I divide them. 13 divided by 40 is 13 divided by 40 equals 0.325. And that's done. Final answer. Submit answer. Yay. Okay, let's find one that has a repeating part, because I need to show you how to write down the repeating part. 2 over 5, 2 divided by 5, that's going to be 0.4. Okay, your calculator will tell you that. So these are like calculator problems, but I need you to know how to do these on a calculator. They're fast. Okay, 31 divided by 60. Finally, something's going to have a repeating decimal. It's going to be weird too. 31 divided by 60 is 0.516 repeating. 6 is forever. Don't let that 7 fool you. It's just the last 6 is rounding that 6 up. So what I do is I put the non-repeating part here, 5, 1, and then put the repeating part under the bar. And this is the way we show these types of numbers. Okay? When a number repeats after a decimal forever, you just put that bar on top, and that means 6 is forever. Hooray! Okay, so that's how those types of problems are solved. Now let's do convert terminating decimals to fractions. 0.355. Great example, Delta Math. Thank you very much. So what I want to do here is, let's say I had this problem. Convert this to a fraction. Most people don't have a problem with saying that's 3 over 10. Okay, this is the tenths, and that's 3/10 of a whole, so that's 3/10. Now, what if I had 0.35? Many of you also know that this is now the hundredths place, or this is like percent, so I can write this as like 35 per cent per 100. Okay, and then that would reduce. The factors 5 would come out, and I would have 7 over 20. Okay, because 7 times 5 is 35, and 20 times 5 is 100. Now, what if I have 0.355? This confuses many of you. But notice the pattern here. This is over 10. This is over 100. This one will be, this is the thousandths position, so this will be 355 over 1,000. All right? Now, let's reduce that. All right, we might need factor trees to do that. So here's how I might do a factor tree for this one. I might be like, all right, I'm getting a calculator out. Let's say I want to get a calculator out for this one. 355, I can see that it's divisible by 5 because it ends in a 5. So let's divide that by 5 and see what we get. 355 divided by 5. Now, I think it's really useful to be able to do these in your head and find that it's 71. But if you can't do it yourself, then you want to do that. Okay. Now here, this is 71. Okay. And 71 is prime. How would you test that? You could look on your times tables and see if you see it anywhere, and you won't. Or you could test it to divisibility by all the things, and you'll find it's not divisible by any of them. Okay, so this will be equal to, now let's do 1,000. All right, 1,000 take out of 5 gives us 200. All right, so now we have our answer. This is 71 over 200. All right, go ahead and put that in. 71 over 200. Good. All right, so this is how we convert terminating decimals to fractions. That was a good enough example. We'll keep going now. All right, now, improper fractions and mixed numbers. Okay, so this is another topic that many people wanted to review. So let's review it now. We want to convert 9 and 4/5. So this is very nearly 10. One more fifth and it would be a full 10. But right now it's just 9 and then 4 parts of 1. All right, and we want to convert this to a fraction. So because it's very nearly 10, I expect it's going to be very, very close to 50 over 5. It's actually 49 over 5. Let's see why. When I find out how many fifths this is, I could do this. I could say 9 times 5 over 5. I'm not changing that 9 plus 4 over 5. This is still 9, but I'm going to multiply it by 1. And that gives me 9 times 5. This is 9 over 1. Top times top gives me 45 over 5 plus 4 over 5, and that's 49 over 5. A couple more. Yay! Convert 9.5 to an improper fraction. But I wouldn't usually write out that many steps. I'll show you what I would usually do. 9.5 is equal to 9 times 2 plus 1 over 2. 9 times 2 plus 1 over 2. Okay, and that gives you this. 9 times 2 is 18, plus 1 is 19 over 2. Put that in. 19 over 2. Hooray! Hooray. Okay, now let's look at one more. Oh, we still want to convert. So I'm looking at that. 1 times 9 plus 8 is 17 over 9. All right, let's do one more. Okay, I got it. Oh, it wants me to do another one of these. So 9 times 3 plus 2 is 29. 9 times 3 is 27, plus 2 is 29 over 3. Enter. Hooray. And then, oh, here we go. Convert 13 over 3 into a mixed number. So this is going the other direction. If we want to show this as a mixed number, then what I need to do is figure out how many 3's are in 13. So I know that 13 could be written as 12 plus 1. 12 is the biggest multiple of 3 that's in there, over 3. This could be written as 12 over 3 plus 1 over 3. And then this would be 4 and a third. 12 over 3 is 4, and then 1/3 is 1/3. So that's how that one would break down and crumble before your mathematical might. Other ways to think about this one? Well, I multiply 3 as many times as I can to go into 13. And that would be 4 times. Okay, or I just divide 13 by 3 and I'll find this number. Okay, if I just want to like find it on a calculator, I go 13 divided by 3 equals 4 and then some. 4 and then something. Not quite one more, not quite 5, but a little bit more than 4. So then I could do 4 times 3 is 12 and find that, and see 13 is 12 plus 1. It's another way I can find this number if I can't just spot it. So let's put that in. 4 and 1/3. Right. Okay, next topic. This is a really fun one. Tables of equivalent ratios. So Nakisha was driving down a road, and after 4 hours, she traveled 80 miles. We want to know if at that speed, how many miles could she travel in 12 hours? If you're shouting at your screen 240, you're doing well. If you're not shouting at your screen, but you're thinking it here, good for you. Now let's see about how we can use this tool that they give us to find that. Okay? Fill out the table of equivalent ratios until you've found the value of x. So let's multiply by, I don't know what, 2. I don't know. Let's try 2. Okay, we multiply by 2. Oh, I thought we could get the right number of hours. But it turns out that if she travels for twice as long, she'll go twice as far. Okay, all right. Well, let's try and multiply by, I don't know what. I don't know. Let's try 3. Okay, there we go. Oh, if she traveled for 24 hours, a full day, she'd go 480 miles. But I only want 12 hours of travel. I don't know how far she goes in half a day. So let's, I don't know what, divide by 2.
It's under my name.
Welcome back, everyone. So, yeah, we multiplied by 3 and we got a full day of travel. She does 480 miles in a day. So let's divide by 2, go. And we find that, well, she would go 240 miles in half of that time. Oh, and I think I mentioned that number before. So after driving for 12 hours, Nakisha traveled 240 miles. There it is there. Boom. Yes, I want to submit that answer. Yay! Okay, so we make a table of equivalent ratios, right? So you can use a table to answer these ratio questions. It's pretty cool. I didn't actually have that method before, using a table, and now Delta Math has taught me something new. All right, so let's keep going. All right, one-step equations with multiplication. All right, so let's, we have now here, how do we read this? It says solve for S. What does that mean? Well, that means we want to solve for what value S has in this equation. So S is a number. We don't know that number yet. Actually, I know that number, but you don't know that number yet, maybe. Maybe you know. And so what I'll do is I'll copy down this equation here. So I want to write down this equation here, which is 12 multiplied by some number equals 72. Or we can put a little story together. I went to the store and I bought 12 snakes, and that cost me $72. How much does one snake cost? Is this type of question, okay? So how are we going to do that? Well, what we do is something called inverse operations. Whatever's being done to your variable, do the opposite. So here it's being multiplied by 12. The opposite of multiplication is division, folks. So I'm going to divide both sides by 12. And then I get the next line. The 12 and the 12 cancel. And so I have S is equal to 72 over 12, which, oh, well, let me check that on my calculator. All right. You can check it on a calculator if you want. Okay, you don't. If you don't need to check it on a calculator because you're. Please stay hungry. Please don't eat the bananas, like I just said. Go. So let's take a look at another problem. 12 is equal to negative 4 times some number. I love working at home, everyone. You're really lucky that you get to not have distance learning with me, because it's like this all the time during class. Okay, all right, and we love them so much. Okay, 12 is equal to negative 4 times some number. What number times negative 4 is 12? Well, right now we're multiplying this number by negative 4, so let's do the opposite of that. Let's divide it by negative 4. I'm going to divide both sides by negative 4. Right? That's my little strategy there. That's my little trick. 1 second. All right. And why am I allowed to do this? Why am I allowed to do these things to these equations? Let's take a little break and we'll talk about the why. Okay. Oh, maybe we should finish this question first. I'm all over the place today. -4 divided by -4 cancels. Just leaves me n on this side of the equation. Hooray, that was my goal, to get something like equals n. I want to know what number equals n. 12 divided by -4, ask your calculator. It'll tell you it's -3. Here's the answer that we're going to put in here. Why am I allowed to do these things to both sides of the equation? All right, let's cover that idea. Suppose I have 3 elephants on one side of a scale, and it tells me that they weigh together 3,000 kilos. And I want to know the weight of one elephant. Well, you can probably look at that and say, well, one elephant's got to weigh 1,000, Mr. Jennings. Yeah. So let's use inverse operations to find that. Divide both sides by 3. Ta-da! That's now 1. Okay, so the elephant weighs 1,000 kilos. All right, so that's one direction. Well, that's one way of doing it. But now I don't want you to imagine this because it's far too grotesque to imagine. So you just have to not visualize half an elephant on one side of the scale. Okay, if I have half of an elephant on one side of the scale, it would probably be very messy and it would weigh 500 kilos. Okay, now in order to undo this division, I multiply both sides by 2. Because multiplication is the opposite of division. This 2 on the top cancels that 2 on the bottom, and we're back to elephant is equal to 500 times 2. Okay? What I do to one side of the equation, I'm allowed to do to the other side of the equation, because ultimately this equation is like a kind of scale. And if this side is just as heavy as that side, it will be balanced. And that's one way of understanding an equal sign, is it's saying this is a scale with the two sides balanced. If I said, if I changed that and I had instead an elephant is known to weigh more than 1,000 pounds, then it's not a balanced scale anymore. It's more like, like this or something, where more like this or something, where this side is much heavier than that side. Okay, but it's not like that. All right, and we're back, and we've had some participation here. So now let's go find another problem here. Okay, here I need to divide both sides by -9, and I find that w is equal to 5. Here I divide by 11, and I find t is equal to -4. Here I divide both sides by -8, and I find that s is equal to -6. I want a division one. They're all the multiplication. Oh, sorry. Okay, let's go back. I'm not trying to flex on you. I'm just trying to show you. And then here, these are harder ones. So these ones, why are they harder? Well, they should give me fractions. This one's no harder. R is equal to 2. 8 times some number is equal to 16. Well, that's 2. That number is 2. Now, I can divide both sides by 8 here, and 16 divided by 8 will be 2. But sometimes they're harder, like this one. Okay, so now 19 is equal to 2 times some number. So let's copy it out. 19 is equal to 2 times some number. And now I see, well, I don't want to know what 2 times the number is. I want to know what the number is. So divide away that 2. But I have to do it to both sides or else the equation's not balanced. So now I get this. T, because these cancel, is equal to 19 over 2. But Mr. Jennings, what do I do with that number 19 over 2? You leave it as 19 over 2, folks. 19 over 2 is a perfectly valid way of thinking about that number. It's a little bit less than 10. It's 9.5. 19 over 2. Hooray! If you wrote in 9.5, that would be fine. Okay, let's do one more. Okay. All right, 7 is equal to 11t, so t is equal to 7 over 11. You can do these fast without writing them down. That's fine. 10 is equal to -4a. So this is equal to -5 over 2. The factors 2 cancel away, and I get -5 over 2. -12x is equal to -10. So x is equal to 5 over 6. Okay. 7 is equal to 8n. So n is equal to 7 over 8. If you can start doing these fast in your head, it's quite fun to do a number of them in a row. Okay, let's do some division ones. One-step equations with division. All right, so here we have a variable, and it's hiding inside this equation, and it's being divided by some number. So let's go ahead and we'll try and find that number there. -1 is equal to u over 7. I don't know what that number is divided by 7, so let's get rid of that division. The way we get rid of the division is by doing the opposite, which will be to multiply by 7. I'll write that as 7 over 1 just for fun, but really it's just multiply by 7. And then on this side of the equation, I'm going to multiply that by 7 as well. All right, now this 7 cancels that 7. So all I have left on that side of the equation is u. 7 times -1, well, that's -7 is equal to u. There's my answer. All right, -7, enter, enter. Hooray! Let's do another one. 3 is equal to 2 divided by x. All right, so let's write this down. 3 is equal to x divided by 2. I read that wrong. All right, so now I'm going to multiply both sides by 2. And I have 2 times 3 is 6. 6 is equal to x. Okay, put that in there. Hooray! That's how you deal with division. You multiply them away. Now, let's do the add, subtract, and the equations with positive decimals. Oh my goodness. All right. Okay, -4 plus r is equal to 8. Okay, now we're going to be looking at addition and subtraction where those are messing with our variables. All right, so here, let's copy it down carefully. -4 plus r is equal to 8. So if I start at -4 and then I add some number, I get to 8. I could use a number line to structure my thinking here. 0. This is -4. That's where we're going to start. Plus r gets me to 8. This is r, okay? If I start at -4 and I add r, I end up at 8. Well, it's 12, okay? So how do I do that with inverse operations? Here, I'm basically subtracting 4 from r. So if I add 4 to this side of the equation, -4 plus 4 is 0. But I have to add the same thing to the both sides of the equation. Similar to multiplication and division, where here I have subtraction, so I add, which is the opposite of subtraction. And it's the same idea with the elephants. Let's say I have an elephant plus a person. And I know that the scale is saying that's 1,100 kilos. Okay? Let's say I know also that an elephant equals 1,000 pounds. So I'm going to subtract the elephant from this side. I'm going to subtract 1,000 pounds from that side, which is the weight of the elephant. I'm subtracting 1,000 from both sides. And then what do I get? Well, this is 0. This is 0. And I get the weight of a person is 100 kilos. Okay? I can subtract the same thing from both sides, and it also works. I can add something to both sides. If it's easier to measure, I could put more people on either side of the equation. So long as I put the same number of people on either side of the equation, it still balances. So this was 12. Another. -1 is equal to -1 plus s. Okay, s is 0. All right. Something is equal to something plus some number. Well, the only thing I can add here that wouldn't change it, that would make -1 equal to -1, would be 0. So it's 0. Okay. Another thing I can do is add 1 to both sides. If I add 1 to both sides, it takes away this -1, and because -1 plus 1 is 0. So I would have, and then I would have -1 plus 1 is 0 on this side. So s is equal to 0. Okay, very much is equal to 0. Next problem: 1 is equal to -7 plus b. B's 8. Okay, because I add 7 to both sides. -7 plus 7 is 0. So what I have here is something looks like this. 1 is equal to -7 plus b. Okay, add 7 to both sides. 1 plus 7 is 8. 8 is equal to this. Here is 0, so it's gone. And I'm just left with b. 8 is equal to b. Hooray! Okay, so that's it with addition and subtraction. Let's do with positive decimals. Cool. 17.3 is equal to x minus 2.1. Okay, so we write it out. 17.3 is equal to x minus 2.1. I use that number 2.1 a lot. It was on our test. So what do? Have no fear. Just add to 0.1 to both sides of the equation. Okay, and then I get 17.3 plus 2.1, which is 19.4, is equal to x. 19.4 is equal to x. X minus 7.8 is equal to 17.7. Well, I have x minus 7.8 is equal to 17.7. Add 7.8 to both sides because I'm subtracting 7.8 from x, so let's add it back. So this is 0, but I have to add it to both sides. And then this is x is equal to 17.7 plus 7.8. So that would make that an 8. So it's 25.5. See if I'm right. I had to carry some numbers there. I'm not entirely sure. Hooray! Okay, so that's how you do those. So we've done those. So let's take a look at some proportional reasoning to finish off. Okay, Claire bought 10 chicken wings for $17. If Claire spent $5.10 on a different day, okay, let's say one day she spent $5.10 and another day she spent $17. How many chicken wings did she buy? First, I'm going to guess that it's 4. Maybe 3. 3. I'm going to guess 3. All right. So having that guess helps me check my answer when I get something back. If I get 30 back, then I probably did the thing in the wrong order. Okay, so here's what I do. 10 chicken wings equals $17. This is how I would do it. And then I want to find the price for one chicken wing. Well, does that really help me? Yeah, I can use that. I could do it this way. So sure, I'm going to do it this way, and then I'll show you another way to do it. All right. I'm a little bit like just brute force these things. So there, I divide both sides by 10. Why? Because I want to find the price of a single chicken wing. So a single chicken wing costs $1.70. Costs $1.70 because 10 of them cost $17. Right? So now I figure out how many times once $1.70 goes into 510. Okay, and I'll find that it's 3. Okay, so I put now here $5.10 equals the number she bought multiplied by the price of them. Okay, that's the number that she bought on this day here. Okay, so let's check that. Now I divide both sides by 170 to get it away from the number that she bought. Okay, and then maybe I need a calculator to do this one. I'm just so confident that it's no, I can do that in my head, but you'll need a calculator. So move the calculator, Mr. Jennings, so we can see your numbers. Oh, it's so big, the calculator. 510, 5.10, okay, divided by 1.70 equals 3. Okay, there we go, 3. Okay, cool. All right, cool. So that's how many chicken wings she bought that day. Hooray! Let's do another. Joseph, it cost him $21.90 to send 146 text messages. Oh, I promised you a different way to solve this one. I don't care. If you want to choose figure out your own way, good. That's fine. My way is really good too. Okay, 21.9. Your way is better than my way because it's yours. All right, so $21.90 per 146 text messages. So this is equal to 146 plus the cost of a single text message. So multiplied by the cost. 146 text messages multiplied by the cost of a single text message gives you this. Okay, so that's an equation I can build here. How many text messages did he send if he spent $6.45? Well, let's go through the same process. Here I'm going to divide both sides by 146. I almost don't want to do this in front of you. I want you to figure it out yourself. I want you to struggle. And here I am showing you a method that you'll just try. Why don't you just struggle with these instead of having me solve them for you? Okay. Figure it out. And if you can't figure it out, ask me about it and ask me questions in class. Proportional reasoning with percents. Let's go. All right. So 4,500 people attend a football game. If 2 of the people attended who are teenagers, how many teenagers attended the game? Okay. So here, divide, scale down to solve for the missing percent. Attendees. 450 attendees. 2% of teenagers. How many teenagers attend the meeting? Well, I mean, what do they want me to do here? What happens if I put in 100 or something? Percent. I don't understand what I'm supposed to do. Divide, scale down to solve for the missing percent. Let me try this here. So 2% of this is, what is it? 2% of 500 is 10, and 2% of 4,000 is 80, so it's 90. 90 attendees were teenagers. So I'm just doing the math. I'm sure I want to submit that answer. Yay. Okay. So what is here? What is this doing? What's this divide by thing? I don't understand the interaction here in this assignment. That's strange. 100 divided by 2 is 50. Okay. So what they're saying is that we can use some logic to say what's 2% of that. This is 100% and it's 4,500. And then what do we need to divide by to get 2? Oh, that's what they're doing. So they're saying divide this number by 50 and you will get the attendees who were teenagers. Okay, cool. That's a neat way of thinking about it. Great. My way is a little different. I just multiplied by the percent in my head. All right, so my method looks like this. 4,500 times 0.02. That's what I did. Okay. But you'll find that what they do is they said 4,500 and they figured out that they need to divide by 50. Let me show you something cool. Dividing by 50 is the same thing as saying multiply by 1 over 50, because multiplication is the same as division, just on the bottom, right? 1 over 50, what is that? All right, let's take a look. So you can have different ways of doing things, and then you can argue about my way is better, your way is better. You're wasting your time arguing about how to do these things. And you'll find the internet is full of people who said, oh, you did that wrong. You're supposed to do it this way. And I was like, don't you have like video games to play? Why are you arguing with people on the internet about how to do math? Like, why don't you just go and do some math if you love math so much? So anyway, yeah, multiplying by this number is the same as dividing by 50. That's why their method is the same as my method. And I was a little confused as to what they were going for there, but now I know. Okay, so thank you for tuning in. Thank you for showing up for your learning. If you email me orange peel in an email, you send me an email with the words orange peel, and I will know that you got this far in the video, and I will give you a super fist bump. Bye for now, everyone.